Okay, welcome everyone. Welcome everyone. Today is our Sunday and we are going to stream. Not in the evening because, yeah, unfortunately today's evening is busy. But yeah, today what we're gonna do some live coding today. So yeah, as you might understand already, it's gonna be implementing Redis sharding from the. Basically, we're gonna be mimicking the official Redis source code and how the sharding implemented there. Basically, previously we have discussed how it works, like on the top level, how the sharding works and why mod operation works there, and why you don't need to rehash everything. So let me quickly recap this. So how Redis sharding basically works. Pretty a bit similar to consistent hashing in some sense, but yeah, in consistent hashing you also have like this numerical line from 0 to some number n. In Redis sharding, this n is 6k something something, so 2 to the power of 14 basically. And you already have predefined hash slots, and the number of these hash slots is exactly this 2 to the power of 14, and each hash slot can basically take and handle the particular hash slot at the time. So this hash slot is basically kind of a virtual node in consistent hashing, and this hash slot is handling some range of the keys, right? Or basically it's not a range because every single time you're gonna determine the hash slot, you're gonna compute the hash of your key, and the result is going to be basically a hash slot modulo of this 2 to the power of 14. Basically, this is how it works, and why modulo works here, because you are not going to add any more hash slots. So maximum number of physical nodes that you might have in your Redis cluster that is sharded is 2 to the power of 14. This pretty much should be enough for all possible workloads in some, reasonable amount, I would say. So yeah, that's why the modulo works here, because you basically don't want, and you will not be able even to increase number of hash slots, and that's why you then can just move these hash slots randomly between the physical machines as you want, and this is how you basically redistribute the load. As simple as that. And then Redis nodes, they keep this map of hash slot to physical node basically internally, and via the gossip protocol it spreads this config between the Redis nodes, and that's basically how it works. But today, since we don't have much time, we're gonna implement one. So let me just create very quickly a solution. Of course, it's gonna be .NET solution for now. I might actually think about focusing on maybe just in memory implementation in some sense. So yeah, let's see how it goes. Later on, I think we can even extend this to some real-world POC, in which sense that we actually can create Kubernetes clusters, for example, and yeah, and then we can reshard it on our own. Yeah, so let me basically create. So what I want. Empty. What is empty? Okay, let me check web API. Okay. This thing gonna be called. Yeah, just setting up the project just for your information, so you know what's going on here. So let me name it Redis sharding or hash slot sharding, something like that. And let me first create this guy. Okay, it is here. Nice. Do I have Copilot? It will be actually very handy in this case. So ChatGPT 4.0 mini, whatever. Okay. Very nice, very nice. So syncing projects, let it load basically for now. Yeah, perfect. But for now, I would say, yeah, we can leave this API as it is. We don't have to move to controllers because I think we are not going to support that many operations. So what I want to see is adding key, reading the value, reading the value by the key. So basically basic cache implementation, I would say. And what I want to have behind that is that we have these hash slots, we have bunch of nodes, they can communicate between each other, and well, I'm not sure what else. Yeah, this should be basically enough. We're gonna do it same way as real Redis, as how real Redis works. So basically, let's do it once threaded. It's gonna be just once threaded scene. So we're gonna create some singleton and probably, yeah, I don't really remember. We can do it as a queue and process queue one item at a time. Or how else I can do. I actually forgot how to do a single threaded application in .NET. You can basically apply some locking mechanism completely, and yeah. Actually, I think the good way of doing that is to actually ensure your application is working with one thread only. But I think, yeah, for now maybe just locking would be fine. Let me actually double check with GPT this thing. So how can I create singleton service in .NET and make it working in single thread manner? Is there any better way to do this? Yeah. Yeah, via semaphore we can do this. Serialize words, only one operation runs at a time. Yeah, semaphore slim. It's async locking in this case. Only one request at a time. What is this queue? Channel. I have no idea what is it, but okay. Okay, let me do this simple locking mechanism. So, yeah, or maybe I wanted to do it somehow like cross-cutting concerns. In this case, maybe I can do it in a middleware or something. So yeah, idea I don't want to do. Okay, so let's then first create this single thread locker middleware, which will ensure that basically we are running all operations in one thread, as real Redis does. Yeah, and that will be it. So okay, what I want to do, create me a middleware. Just create me a middleware. Yeah, let's say it will be login middleware, whatever. I don't really care. It will be locking or one-threaded middleware, whatever. Seri execution middleware. Yeah, and then let's basically copy this. Yeah, and here what we're gonna do is exactly this thing with semaphore, which ChatGPT proposed to us. So basically, semaphore slim. Initial count 1 1, exactly. And now whenever we're invoking something to make it in serial order, yeah, thank you. So while this thing executes, only one thread is going to execute this, basically delegate the next chain of responsibility, or whatever this pattern is called. So I'm pretty sure you should be aware of middlewares. And now we're gonna use this middleware somewhere. App use middleware, where it should be used. So I think somewhere here. Nice. Now these summaries and all this bullshit we don't basically care about completely. We don't care about this boilerplate at all. Nice. So now all our operations are going to be executed in this one threaded middleware, which is pretty good. And now let me create. So how do I design this? I definitely need something like hash slot node or something. So one node might, let me define it as a, I don't know, shard. Let me define it as a shard. Yes, add everything to GitHub, come on. Yeah, by the way, guys, it will be available in the GitHub page, right? So, okay, so in our shard, what do we need to have? How in general I want to design this? So let's say I have this single threaded service. I need to have some shard. This shard for sure has some dictionary of key value, right? This shard is going to be responsible for one hash slot. And also what I want to do, I want to have some information about cluster. So every single shard basically should have also information about general cluster and other shards. To know, for example, if some request for hash slot that this node doesn't have came in, it can redirect to another node, for example. So we kinda should have So let me define it in this way. So every single shard, this is shard, is going to have cache itself, which is basically the thing that is responsible for the key value pair. It's going to be kind of service as well. Then this shard also going to have, since we're going to do a gossip protocol on top, let it have also all information about the cluster. So something like cluster information or something like that. And also, also one complication here is that shard can actually handle multiple hash slots. It can handle multiple hash slots. So what do I propose to do? Is that shard gonna have not a cache, but just a hash slots, this array or map, whatever. And it has and it has references to something that we call node. let's say yes, let's say something that we call node. Or to simplify it, I actually don't want to mimic exact thing that this official Redis thing is implemented. So what we can do is maybe to have like local slots as a map or dictionary, whatever, and we're gonna have kind of remote slots. Yeah, and then when we are doing sharding, for example, we might add local slot and remote. Okay. That kind of makes sense. Not sure is it the best way or no, we can refactor later, but let's do it like that. So we're gonna have not shard, let's rename it to node. Please, this thing also should be renamed. And node, what is going to have? So it's going to have a dictionary of. It's going to be integer, right? Yes. And something that we called local slot. Local slots. And this guy we're gonna create just now. Not directory, let me just add pure class. Yes, exactly. And this is gonna be local slot. Of course, it's gonna be not settable at all. Just new. And we got, okay, let me actually put it to some directory, exactly. So, why it does not update it? Oh my god, Rider, what the hell are you doing? Good. So, now we also want to have something like remote slots. Oh, shit. We don't care about optimization at that point. So actual Redis is doing it via bitmap and via array and a lot of different other optimizations on top. We can work over the maps. I think it should be quite okay in this case. So what do I want to do here? Yeah, this is our node basically. We might have different nodes. Yes. For now, let's leave it and let's implement the remote slot and local slot. So local slot in our case is going to represent the specific one hash slot in Redis shard that is handling a set of keys that landed on this specific hash slot. So slot ID, okay, let it be. Then after this, this going to have dictionary, and dictionary is going to resolve like int. This is gonna be to be hash of the key, or should it be the key itself? So we're gonna take the hash slot ID, which is going to be hash key. So this is going to be, no, I would say this is going to be just key as a string. Let's say we have keys as a string, and on top of that we have string as a value. So let's assume that for now we only have key value pair that can be string to string. dictionary cache. Exactly. And now how we want to add it into our pipeline is that we have some node. This is not going to have method like public, I think, task, something like this. Yes, and also we're gonna have hash. I know I don't want to name it hash helper or hash service. Let's name it. And this I want to ask for ChatGPT. So give me some language agnostic hash generator for .NET. We don't want to use native hashing, you know, this get hash code from the object, from the string, from whatever. Because as far as I know, in .NET between the restarts, the hash will be changed and basically will not be able to get and to set the same key at the same position basically. So what the hell is this? Give me NuGet, come on, bro. Can I actually use the real one, the real thing that Redis is using? So Redis is actually using CRC16. It should be somewhere mentioned, I guess, in cluster H. So cluster H header, it's C. So yeah, you're gonna find that, yeah, we have this 16K hash slots, as we already discussed. The hash slot of a given key is obtained at least significant 14 bit, yeah, blah, 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 of the CRC16 of the key. So let's try to do this in NuGet. Do I have anything? So it's 14 significant bits. We actually do exactly the same thing. Okay, please help me. NuGet. We have something here. I don't know, it seems like... Let me actually double check with GBD, of course. Yes, random. Okay, so let's then use this guy basically. What is the documentation, and do we have at all the documentation in this case? How to use it? Get bytes, compute checksum. Yeah, this was used. Hello. So this CRC hashing algorithm that is used in Redis is actually used for checksums, but Redis decided to use it on their own. So CRC compute checksum text buffer. Okay, let's just use it. Can I install it? Install, exactly. And here we are already going to do compute slot ID exactly. So here we're gonna have some 2 to the power of 14 is basically the case. 2 to the power of 14, 384 exactly. So this is legit implementation of the Redis sharding, exactly same number of hash slots. So as we have this thing, let me just basically copy paste this thing. This is uint, and we need to get the 14 14, what was this? Least significant 14 bits, so we basically shifted to the left. All right. Hash. Now. I don't know, slot. Okay, it's not a slot, but least significant. It's going to be hash. Power of 14. I guess this is the least significant, right? We get hash. And we move it. Oh my god, no, this is not how you do it. So basically what we want to do is we want to do AND, and we want to, so how this thing works. Let me explain for those who are not very familiar with the bit numbers. So let's say this is our bit representation of the hash that we just generated, and we want to do 14 rightmost bits. How to do it? Basically you do AND, you do here zeros, and you do 14 ones. So basically it will basically leave only this part. But how do I do this mask? Oh my god. Okay. Let me check hexadecimal, I don't know. To binary. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's a bit. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. That is 16 bits. Made 14 bits. What if I do this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh my god. How did Redis? Ah, yeah, exactly. They did it like that. So this is, yeah, this is how they did it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Exactly, this is what we need. So Copilot failed here ridiculously. And then, as we have these 14 significant bits, we're gonna return them. Yeah, so we just return least significant modulo total slots, so we don't overflow. And what wrong with, okay, I can convert it to int. I don't know what you're doing, but I'm here after watching backend is harder than front. Hello, yes. Yes. What I'm doing the Redis Sharding implementation POC. Okay, so this is how our hash service is going to work, and we're gonna add it somewhere here. Now we want to go here. I don't remember which one goes first. Just need to check one thing quickly. Yeah, this one. So property, what goes first, properties or constructors? Constructors. Good. So now here I want my hash service. Exactly. Pretty good, pretty good. And now slot ID is going to be coming from this hash service compute slot ID from the key. Nice. This is not going to be a regular exception. It's going to be a redirect. It's going to be a redirect exception. Do we want actually? No, we don't want. So it's going to be node response. Status. So I want status because I want to have two statuses. Basically, it's basically three status. Okay, error. I want to have status redirected. So basically, go to different node. And in this case, this guy is going to be a string response. And this response might be dynamic. It will be dynamic. So in case of redirected status code, it will, for example, return the URL of another node ID or shard ID that contains this specific key that we want to obtain or set. Or it can contain the response if this key is already here. So this is how it's gonna, it's not the best design, I have to agree, it's not the best design. So no response. So in this case, one thing though that every single node, now I'm actually questioning my decision about, is this some kind of Vim mode in Visual Studio? Yes, it's Vim motions for either. Yeah, so basically this is completely Vim thing. Yeah, now I'm questioning about my decision to have two maps and questioning decision about having them as an array. I'm questioning this decision now. Because it can lead to inconsistencies, right? How are we gonna remove then this slot? So when we have one node, all the slots, all these 16K are going to be handled only by this local node, right? And then when I'm resharding and I'm adding another physical node and want to move a bunch of hash slots, what I want in this case is, how do I do that? I will remove them from local slots and put them to remote slots. No, I disagree. I don't like this approach, so I will rewrite it a bit. So we have hash slots. They're not gonna be such thing as a remote slot completely. It's gonna be just a hash slot here. Just like that. It's going to be slot ID. And node is going to have its own yes, private node. Should be string. No, it shouldn't be string. It should be int. Node. And how we're gonna detect whether the node is local or not is basically, yes, is basically determining yes, something like that. Great. It's going to be hash slots, and now if actually, yeah, in this case, if hash slots does not have slot ID, it's definitely an exception. Otherwise, yes, otherwise, slot, we're gonna resolve the slot from hash slots, slot ID, and then slot cache, but this is read-only, so what we are doing is public async task this for future because it might apply some async C. Something like that. Why this thing is so happy? Let's decouple this thing. Exactly. And now for this guy, we're gonna implement get async. And let's do it in simple way. If Thank you. Yes, as simple as that. Should be actually enough. Do I know this node ID? I'm not sure I do actually. So yeah, in reality, the Redis has its own, how to say, its own query language, right? Like this set and nix and stuff like that. So for this, you need your own like parser, Alexer, and all this stuff. In our case, we're gonna do it in a simplified way. What I mean by that is that we're gonna have only just two operations because yeah, it's POC. We don't want to create our own Redis language here, right? It's not the intent of the video, not the video of the stream basically. Yes, so we have slot. Yeah, two operations are implemented now. This is basic scene for this thing to at least work, right? Now what we want to do is to understand, first of all, yeah, get slot. And it's gonna be copy paste. It's going to be copy paste a bit, but okay, if slot node ID not equals to node ID. Not very happy about this code, but okay. All right. Yes, something like that. Something like that. Now let's try to implement very fast how we're gonna add the hash slot. So how are we gonna initialize this scene? Now I'm thinking, should we do it in memory or should we emulate the real Kubernetes scene? Not sure though how we can do it in memory, and can we do this? Yes, I guess we can do it in memory. For that, what we need to do is this this guy should be able to be replaced by Kubernetes later on. Let's name it as node manager. And when we set up the yes, so public all right, and now how do we initialize it? Or maybe not initialize, it's going to be something like get update, or since we're gonna use gossip protocol, right, there should be some endpoint listening to this gossip protocol or whatever else, somewhere from where we can get the input. And from this gossip protocol, we're gonna have the configuration snapshot in a sense. Right. And this configuration snapshot, we're gonna have ID, yes, so that's interesting one, how we're gonna do it, how we are going to do that. We receive configuration snapshot and then we should populate it in some sense. So initialize node is going to be the node that receives at least one, at least one snapshot. So yeah, this is going to be process configuration snapshot. And we're gonna have configuration snapshot or cluster snapshot. Yeah, and this thing, what it should have inside, I guess it should just have array of maybe nodes inside. Yes. So what it should have inside is basically this dictionary, but it, as we decided, it shouldn't be dictionary because we have static number of slots. So it should be just array of hash slots. How to do it? New. Oh my god, how is it initialized in .NET? Total slots. Okay, in hash service we have it. So hash service. And we cannot refer it to a single instance. So hash service total slots. What do you want from me, .NET, please? What the hell you want from me? Implicitly type array should have initializer. I didn't code in .NET for a very long time, and I don't really know what is the problem here. And I'm not gonna spend any more time on this. What I'm gonna do is a true pro developer. I'm gonna paste it to ChatGPT so it can fix it. Because I don't want to do this. Yeah, I didn't code such core things in .NET for a very long time. Oh my god. This is new feature of .NET, I'm sorry. I'm so used to it, so I even forgot how it was before. Okay, now we have these hash slots, and our configuration snapshot or cluster snapshot is going to be exactly this thing. We're gonna serialize it in JSON or something like that. I guess we can do it in JSON. And yeah, this is the cluster snapshot we're gonna receive here. Also, it should have a string int version. It's kind of DTO, so we put setter. It's okay. And now what we want to do is this guy also should have what it also should have. The version. And now take a look how we're gonna proceed it via gossip protocol. So if thank you Copilot, it's very handy. So if snapshot version is less than or equal our current snapshot version, we basically don't care about this configuration because most probably we have all up-to-date value. If the snapshot version is actually our current node snapshot version is less than version that we get received, we're gonna process the configuration and basically update everything, but I'm not quite sure should we update anything about ourselves. Most probably yes, because if node gets disconnected for a very long time and all this literal action resharding blah 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 happened, that time the node might not own the hash slots it had before, so it should just accept whatever it has in the configuration with the higher snapshot version, right? So snapshot version is going to be a kind of monotonically increasing sequence number in this case. But we got to be careful. We got to be careful about the node hash slots that we own. So if we received update about hash slot that we own, since we don't want to include in our configuration all the keys that this hash slot has, because otherwise it will be quite a huge bunch of data. In this case, if hash slots node ID equals yeah, so if our hash slots, our node ID equals to node ID that, yes. So if update about this configuration is about hash slot that our node has, and if our node still has this snapshot, so basically nothing changed, and if snapshot hash slots is node ID equals node ID, don't change anything. Otherwise, yes, change it. Putting comment here that in case if current node keeps handling the slot was before, don't change anything. Do not clear the key value pairs. So for your understanding, go a bit deeper here. So we are handling hash slot, right? And every hash slot has this cache. And for the nodes that, for the hash slots that current node doesn't handle, this thing gonna be empty. And we don't want to propagate a hash slot. I mean, we don't want to send a cache, so key value pairs over the configuration snapshot, because in general, your hash slot might have dozens of thousands or even hundreds of thousands of keys, right, in your cache. And if you want to include it in your configuration change, imagine you have ghosty protocol that transfers megabytes, like hundreds of megabytes data. It's not feasible completely and it will not work properly. So our configuration snapshot going to include only the hash slot that is basically, I wouldn't say it's hash slot, it's maybe even hash slot, maybe it's hash slot header, let's name it hash slot header, whatever. Hash slot header that is basically exactly same, but it does not have this cache. So maybe let's even do, since we need only ID, not ID, maybe we can do it even better. In this sense, we can do it as ints yeah, something like that. And in this case, if we go back to our node, exactly, this is how I do it. This is how I do it. And in any other case, maybe we even can do this as this. Can we use inheritance here in this case? Let's maybe not do it. Let's just assume that hash slot might have this thing empty. If not, ID is remote, not cache will be empty. Let's just put it like this. Great. And in other case, yeah, what we're gonna do, we're gonna just Yeah, exactly. Otherwise, we just override whatever we got from our configuration snapshot. Great, 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 great. And in this case, initialize set to true. Good. But how our initial node creation is going to happen? Maybe let's set everything to our node ID, basically. So how it can be done, like hash slots. Is going to be new hash slot. Or how to I equals 0, I less than hash. And in this case, I guess we can do initializing here. No, please don't do this. And initially, we put it to our current node ID. No, yeah, like this. Yes, 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 yes. So once the node created by default, it assumes that it handles all the hash slots it has. Now, what we're gonna do? Great. Should be actually read-only collection, maybe, but whatever. Let's think about encapsulation a bit later. So if this validation can be done a bit easier, if slot ID less than or 0 or more than or equal hash slots, then we throw the same exception. Great. Now, do we have any more errors here? Now let's do node manager. Node manager, how are we going to implement our node manager? So, let me check the chat. Yeah, actually not that many people are watching us, so yeah, whatever it is. So, node manager is going to do what exactly? It's going to have some property node list of nodes. And for the first time, since we're gonna initialize it from the not from the DI, but locally, in this case we are doing this. And this guy gonna be initialized from the DI. Exactly, and this going to be nodes. Nice. And now what I want here is to generate a snapshot of the configuration and all the keys that we handle. Okay, why not? Because this way we added a node. Then we need public async task fire gossip. This is for gossip protocol. Also, I want to have async get snapshot. So what I want here, in node manager, please generate me a get snapshot method. It should go through all the nodes, get all the hash sorts, the node handles, send it by ranges. Let's try whether this guy can do this. Wait a moment. Why? Ah, okay. Okay, got it. Not sure it is gonna work actually. Okay, how can I do the how can I do that? We have 16k and we can get only the ones that are handled. Okay, we got range start, range end. Okay, let's believe it will work like that. Okay, that's nice. Fire gossip. Yeah, here I want how to add this. Can I add this up? Okay, in node manager and fire gossip, choosing two random nodes and propagating the update to them. Now when the gossip should be over. Yeah, we're gonna talk about the gossip protocol in the next sessions, and we're gonna implement it. Okay. Perfect. Yeah, let's maybe try to run it. I have exactly 10 more minutes. At least that it runs. Node manager. And here what I want is to return a snapshot from the node manager. Exactly, and initially the snapshot should be completely empty, right? Yes, I love C# and .NET. Nice. Me too. The best language for enterprise backend. Have to agree. All right, let's try to run it really quickly. Exactly this 9 minutes. .NET 8 or 9. Oh man, sorry. I I stopped checking the versions and updates long time ago. And now what I'm doing is only I know that my project there is one specific person that is responsible for updating .NET in my project, and I don't really remember, but I'm using something pretty new. Let me actually check. It should be somewhere in the configuration, right? Open in Explorer. Let me check. So, open with it should be either in CS Proj or in SLN. No, it's in CS Proj. So it's .NET 8. Yeah, .NET 8. Nice. This thing is working actually. Weather forecast. Why the weather forecast? I don't want weather forecast. Snapshot. However, I don't think I need these guys. Okay, it didn't return anything, but now... Okay, we're gonna test it a bit and play with it in the next time. So next time, what we're gonna do? Let me add to do here. So next time, to do add gossip protocol for nodes to propagate the configuration change. Add moving shard to different node, not shard but hash slot. Well, yeah, that's actually it. Not that many things left to implement. Nice. I'm waiting for 10 to drop. I also trust LTS. I'm sorry, I have no idea what is LTS. Long-term support. Okay. All right. So yeah, I got to go, guys. So this thing is going to be actually pushed in my GitHub repo. I will show you which one. Oh my god. So this is going to be the, or not this one. Oh my god. Sorry, fail. A little bit of fail. We have another one, distributed system. So here will be a Redis Sharding folder or something like that, and this code is going to be pushed here, and we will continue next stream to implement our gossip protocol and implement our hash slot moving, exactly rehashing algo. But so far we got to the pretty good point. Maybe we will extend it later on with adding the Kubernetes. So instead of running this in memory, we can actually create a very good POC that is kind of real world and kind of near production ready thing. So let's see how we're gonna do it. Let's see how it goes and how people will be interested in this. And so far, yeah, thank you for being with me. It was me, Andriy. We were at Microsoft Office. Thank you. Yeah, nice to meet you. Nice to meet you too, man. Yeah. So yeah, next time we finishing this, and our Redis sharding gonna be over, and we're gonna move to rendezvous hashing or consistent hashing implementation. I don't really know which one. Okay, Now, yeah, thank you for being with me again, and see you next time. Don't forget to subscribe to Telegram. All updates, announcements are there. See you.